So to graph y equals 3x plus 1, I'm going to make a table of values. And I know this is a line, so I can choose maybe just two different x's. Like let's say I'll use -2 and 0. You could have picked others, but I'm going with those. If I put those into the function, I get -5 and 1. Now if I plot those points, so at -2, I get -5. At 0, I get 1. My equation is the line going between those 2 points. All right, so just a sketch of that line. Maybe I'll just note a couple other things, that the slope of this equation is 3 and the y value of the y-intercept is 1. For x plus y equals 7, I'm going to solve this equation for y by subtracting x from both sides. I get y is equal to -x plus 7. So on a table of values, maybe just getting a couple of points again, I think I'll choose, let's do 0. 0 seems to be a good one for a lot of these. And how about 7? If I put 0 in place of x, I get 7 back for y. If I put 7 in place of x, I get 0 back for y. That's the point 0, 7, and 7, 0. My line goes between those 2 points. There's my equation, and I can see that the slope of this line is -1. It is in fact decreasing, and the y value for the y-intercept is 7. Okay, let's solve this equation for y. I think it's going to be a little bit more difficult, but I'm going to add 1/2 x to both sides. And when I do, I get 2y is equal to positive 1/2 x minus 4. I'm now going to divide both sides by 2. Now, if I divide both sides by 2, maybe I'll put a fraction over here. Dividing by 2 means I'm really multiplying by a half. So what I get is y is equal to 1/4 x minus 2. 2 goes into 4 twice. So in a table of values, maybe I'll have to be just a little bit more careful here. I still think 0 is an excellent choice because you get -2 quickly back for y. And another good option would be 4. If you put 4 in place of this x, you have 4 divided by 4, which is 1. So if you put 4 in place of x, you get 1 minus 2, which is -1. My 2 points are 0, -2, and 4, -1. That makes sense. The slope is positive 1 over 4. We go over 4 and up 1. There's a sketch of my line. And as I said, the slope is 1/4, and the y value for the y-intercept is -2. For y equals 2/3 x minus 3, this one is solved for y. I just need to choose a couple of good values. 0, again, seems to be really good. And I think 3 is a good choice. 3 in place of x gives me a 3 over 3. It would be 2 minus 3, which is, we're getting -1 again, but those are my 2 points. 0, -3. And 3, -1. That is a slope of over 3 and up to positive 2/3. There's my sketch. And as I said, slope 2/3 and a y-intercept of -3. So really could start right here and put a -3, go over 3 and up 2, get your second point instead of using a table of values. So it's kind of up to you how you graph these. For y equals -1/4 x plus 4, maybe instead of a table of values this time, I'm going to note that the y value of the y-intercept is 4. The slope is -1/4, meaning I go over 4 and down 1 because of the negative. So if I place a point here at 4, and I go over 4 and down 1, I get my second point, 4, 3. My line goes between those 2 points. So there is a sketch of my equation. If you're going to use a table of values, maybe just to put that down here, just an alternate way to do this. 0, again, great choice because it gives you the 4 back. And then obviously 4 or 8 would all be excellent choices, but if you put 4 in place of x, you get 4 minus 1, which is 3, and that matches up with our picture. For y equals negative 8x plus 2, the slope is negative 8 over 1 if you'd like. B is 2. So here is b equals 2. Here I'm going over 1 and down 1, 2, 3, 4, 5, 6, 7, 8. That is 1 comma negative 6. And my line goes between those 2 points. So even on a table of values, you could say 0, you get 2. Clearly, if you plug in 1, you do get negative 6. That all matches up. Here's the graph. Not a perfect sketch by any means, but that is it for this equation. Solving this equation for y, I'll add 5x to both sides. And we have y is equal to 5x plus 1. In a table of values, 0 would give us 1. 1 would give us 6. That's 0, 1, and 1, 6. Clearly the slope is 5 with a y-intercept having a y value of 1. And there is my graph. Okay, for 5x minus 5y equals 15, I'm noticing there's a common factor of 5 in every single term, so why not just divide both sides by 5, meaning you can divide every single term by 5. This leaves us with x minus y is equal to 3. And to solve this one for y, I actually think I'll add the y to both sides, which gives me x is equal to y plus 3. Therefore, I will subtract 3 from both sides, giving me x minus 3 is equal to y. For some reason, I like to write it y is equal to x minus 3. And a table of values for this graph is pretty simple. You can use any 2 points you'd like. I'll go with 0 and 3 because I think those are the easiest. At 0, you get negative 3, and at 3, you get 0. So that is 0, negative 3, and at 3, you get 0. My line goes between those 2 points. So here it is. And clearly the slope of this is 1, and it has a y-intercept y value of negative 3. All right, let's sketch this graph using the x and y intercepts. So for an x-intercept, that is going to be a point of the form something for x and 0 for y. Plugging that into the equation, we get 2x plus 5 times 0 is equal to 15. These should always simplify nicely. You get 2x is equal to 15, and if I divide both sides by 2, I get x is equal to 7.5. And the y-intercept is going to be some y value where x is 0, and we have to solve for it. So this time we have 2 times 0 plus 5 times y is equal to 15. That is 5y is equal to 15. Dividing both sides by 5 gives me that y is equal to 3. So those are my 2 points. 7.5 comma 0 and 0 comma 3. Okay, same idea, x and y intercept. So for this one, I don't know the x-intercept value, but y should be 0. That's going to give me 3x is equal to 6. At this point, when we plug 0 in place of y, this whole piece is gone. So I'm just going to simply jump down to this 3y is 6. And if I divide both sides by 3, I get that x is equal to 2. So that's 2 comma 0. Likewise, for the y-intercept, x is 0. I don't know why. And if I plug 0 in place of x, I get negative y is equal to 6. Dividing both sides by negative 1 gives me y is equal to negative 6. So my x-intercept is 2, 0. My y-intercept is 0, negative 6. And my line goes between those 2 points. All right, so for my x-intercept, it's going to be 4x is equal to negative 12. I'm putting 0 in place of y. Solving for x gives me -3. This is my x-intercept, -3, 0. I put 0 in place of y. Likewise, for the y-intercept, I get 3y is equal to -12. And if I divide both sides by 3, I get -4. That is, when x was 0, y is -4. I can now plot both those points, 0, -3. Sorry, -3, 0, and 0, -4. All right, for the x-intercept, we get -8x is equal to 16 dividing both sides by -8 gives me x is equal to -2. This is -2 for x if you'd put 0 in place of y. And likewise, if I put 0 in place of x, I get -2y is equal to 16 dividing both sides by -2 gives me y is equal to -8. That is 0 in place of x gives me -8 back for y. These 2 points are -2, 0, and 0, -8. Okay, this one's going to be slightly off the grid, so I had to extend it just a little bit. But if you put 0 in place of y, looking for the x-intercept, you get -12, x is equal to 12. Therefore, after dividing both sides by -12, you get that x is equal to -1. That's the point, -1 for x and 0 for y. Likewise, if you put 0 in place of x, you immediately get that y is equal to 12. That was 0 for x, 12 for y. Here is 0, 12. Here is -1, 0. I just want the line that goes between these 2 points. Okay, for 8x plus 4y plus 8 equals 8, I'm going to simplify this a little bit by subtracting 8 from both sides, and we are left with the equation 8x plus 4y is 0. In fact, you can even take it further and divide everything by 4, and this equation reduces to 2x plus y is 0. To find the x-intercept, I make y 0. Okay, so let's try that. If I put 0 in place of y, I get 2x is 0, and when I solve for x, x is 0 itself. That's the point, 0 for y and x. But if you repeat this process, putting 0 in place of x, you get y is equal to 0, meaning you have the point 0, 0. In fact, this is a situation where the x-intercept and the y-intercept are one in the same thing. So the x-intercept is actually equal to the y-intercept. So unfortunately, this is the only problem in using this x-y-intercept to graph a line, if they happen to be the same point. It can only happen once. Now, if that does happen, you just need a second point off of this equation that's neither the x nor the y-intercept. So I'm going to go to the equation 2x plus y equals 0 and just try to think of another point that makes this true. If I put -1 in place of x and 2 in place of y, this makes the equation true. That is the point -1, 2. And once I have this second point, now I can graph my line. And that's my equation. Y equaling a number is a horizontal line, and since the y value has to be -4, this is y equals -4, meaning the horizontal line is located right here. And there's my graph. Again, here we have a horizontal line at y equals 2. This is y equals 2. The line is horizontal. This is my graph. The thing to point out is that any spot that you pick on this line will always have a y value of 2, even though x can be anything. X equaling a number is a vertical line. Here is x is equal to -5, and drawing a vertical line at this spot, gives me the following graph. There's my vertical line. Okay, so now we have a vertical line at x is equal to 7. Here is x is 7. That means this is my vertical line. To figure out the equation of this line, I just need to know two things: the slope and the y-intercept. Here's the y-intercept. That has a y value of 3, so I know b is equal to 3. And to determine the slope, I just need to know, if I start at this point, how far do I have to go over and up until I end up on the line again? This one's pretty simple. You can just go over one spot, so that is over 1 and up 1 until I get to this point again. I can see directly from here that the slope is 1 over 1, or simply just 1. If your equation must have the form y equals mx plus b, you can simply just plug these numbers in. Y is equal to 1 times x plus 3, or simply y equals x plus 3. For question 20, the y-intercept is now -2, so b is equal to -2. The slope this time got to be a little bit more. Actually, I don't have to be much more careful. I can go down 1 and over 1 to this point right here. So now my slope, I can think of that as you go down 1 and over 1, or just simply -1 is my slope. Again, all these equations have the form y equals mx plus b. Therefore, my equation is y is equal to -1 times x minus 2, or simply y equals -x minus 2. Okay, for this one, the y-intercept has a y value of 5. And okay, the slope's a little bit trickier this time. It's negative. We're going down. We got to go 3 until we end up at a nice point again. So I can see that the slope is, we're going down 3 and over 1, or simply just -3. So that's down 1, 2, 3, and over 1. My equation, again, they're all the form going to be y equals mx plus b. Therefore, I get y is equal to -3 times x plus 5. For this next one, here we have -2. That's b. And m is going to be over 1, 2, 3, 4, and up 2. I see I could have made this a little easier, right? I could have gone over 1, 2, and up 1. Maybe I'll do that instead. It's a positive slope of, we're going over 2 and up 1. I'll leave it just like this. My equation is 1/2 times x minus 2. So again, for 23, I want a line of the form y equals mx plus b. Here is b, it is equal to 7, and my slope is negative. We're going down 1 and over 1, 2, 3. There's my other point. This means my slope is, we're going down 1 over 3. That is -1/3. My equation is -1/3 x plus 7. For questions 24 through 33, we're going to be using the following formula for slope. It does not matter how you choose your 2 points, in that the order you choose, I mean. So I'm just going to pick one and go with it. So for x1, y1, I'm going to say that is 0, 5. And for x2, y2, I'll just make that this other point, the second one that appears. The slope is equal to, so it'll always be y2 minus y1 over x2 minus x1. Let's see what we get. 0 minus 5 over 5 minus 0. When I simplify this, that's -5 over +5. That is a slope of just -1 over 1. That's my answer, -1. Okay, for the next points, we have, okay, the slope is going to be y2 minus y1 over x2 minus x1. That is 5 over 5, which is 1 over 1. My slope is 1. Okay, so for these points, we get that the slope is y2 minus y1 over x2 minus x1. Here I have a negative, so I just want to be a little bit careful. But we have, negative 11 minus 10 is negative 21 over 5 plus 2, which is 7. This is negative 3 over 1. My slope is just negative 3. Okay, so for the next pair of points, we have y2 minus y1 all over x2 minus x1. Okay, so here in the denominator we get negative 9, yet in the numerator we get 4.5. And it might be worth dividing these out just on a calculator, and what do you know? This is a half, negative 1/2. Okay, for these 2 points, we have y2 minus y1 all over x2 minus x1. And when I simplify this, I get 30 plus 10, which is 40, over 7 minus 7, which is 0. If you divide this in your calculator, you get an error. Anytime that you divide by 0, the slope is undefined. This is a vertical line, so there's no slope. Okay, for 29, y2 minus y1 is 18 minus 18 over x2 minus x1 minus a minus. This is going to be 0 divided by, it's going to be 5.8 plus 2.5, which is 8.3. But 0 in the numerator is completely okay. In fact, the whole answer is just 0 for my slope. This is a horizontal line. Okay, so for this one, the slope is going to be y2 minus y1 all over x2 minus x1. The minus a minus will all become plus. So this is negative 3 plus 11 over 15 plus 9. And 8 goes into itself once, it goes into 24 3 times. Here the slope is equal to 1/3. Okay, here the slope is y2 minus y1 all over x2 minus x1. So, okay, 10.6 minus 13.6 is negative 3 over negative 15. That's going to be a positive number, 3/15. 3 goes into itself once, and it goes into 15 5 times. Okay, so for this one, y2 minus y1 all over x2 minus x1. When I look at this one, I get negative 5 in the numerator, but my denominator, it's negative 4.4 plus 4.4, which is 0. Again, we have division by 0. This is undefined. If you type this into your calculator, it's going to give you an error. And I at least wanted to try one that had a bunch of fractions in it. So here we have y2 minus y1 all over x2 minus x1. So just recall that we can simplify the numerator and the denominator separately if we would like to. So I'm going to move over here. If I think about negative 1/3 minus 1, that's minus 3/3. 1 is the same thing as 3/3. If I take the difference, that's negative 4/3. That's the numerator. So I'll place that in here, negative 4/3. That's being divided by, 3 halves minus 1/2 is 2 halves. Oh, that's just 1. And that worked out pretty nicely. I mean, all right, so negative 4/3 divided by 1 itself is just negative 4/3, and that's a completely acceptable way to write our slope. For questions 34 through 39, I would like to come up with equations y equals mx plus b that go through the given points. So it's a two-step process. We first solve for the slope m. I'm not going to write the formula down this time, but what I'll do for all these points is this is going to be y2, y1, x2, x1. So we have y2 minus y1 all over x2 minus x1. This is negative 1 plus 11, that's 10, over 2 minus a minus 3, that's 2 plus 3, which is 5. The slope here is just 2. I'm going to take that information and put it into my equation. And the only thing that I do not know is b. Now, I can go back and use either one of these points to figure out b by putting something in place of x and the other value in place of y. I'm going to choose this point here. So I'm going to use 2, negative 1. Negative 1 goes in place of y. 2 goes in place of x. The only thing I do not know is b. To solve for it, I can work out that 2 times 2 is 4. If I then subtract that from both sides, I get that negative 5 is equal to b. This is my two-step process. I first figured out the slope using my slope formula. I then used one of my points to figure out the y value for the y-intercept. Here's my answer. Y is equal to 2x minus 5. Okay, first to get the slope, that's going to be y2 minus y1 all over x2 minus x1. Okay, negative 15 plus 12 is negative 3 over 3 minus 2 is 1. I have my slope. I will directly put that number into my formula for the equation of a line. The only thing I do not know is b. I'm going to now choose 2, negative 12 to figure out b. You could have used the other point, but anyways, if I substitute that in, negative 12 for y and 2 for x. If I simplify this, I get negative 12 is equal to negative 6 plus b, and after adding 6 to both sides, I get negative 6 is equal to b. My formula is y is equal to negative 3x minus 6. Okay, the slope is going to be 3 minus 18 over negative 1 minus 2. All right, so that is negative 15 over 1 minus 2 is negative 3. The negatives canceled, give us a positive 5 for the slope. My equation must have the form y is equal to 5x. I just don't know b. I'm going to choose the point negative 1, 3, since the values, I guess, are smaller. 3 goes in place of y. Negative 1 goes in place of x. I just don't know b. That is negative 5 plus b. If I add 5 to both sides, I get my value that 8 is equal to b. And therefore, my equation is y is equal to 5x plus 8. All right, the slope is 10 minus 16 over 4 minus a negative 8. That is negative 6 over 4 plus 8, which is 12. That is a negative 1/2 as my slope. My equation is y is equal to negative 1/2 x. I just don't know b. I think I'll use, I guess, 4 comma 10 to figure out b. 10 goes in place of y. 4 goes in place of x. 2 goes into this 4 twice, meaning this is 10 is equal to negative 2 plus b. If I then add 2 to both sides, I get that 12 is equal to b. My equation is y is equal to negative 1/2 x plus 12. Okay, so for 6,1 and 4,1, the slope is equal to 1 minus 1 over 4 minus 6, which is 0 over negative 2. That's 0. So your equation that you get is y is equal to 0 times x plus b. I just don't know b. You might actually know the answer already, but let's plug in one of our points. I'll use the point 4 comma 1. 1 goes in place of y. 4 will go in place of x. 1 is equal to 0 plus b. There's really nothing to even solve for. B is equal to 1. Here is your equation, 0 times x plus 1, or simply just 1. If you noticed ahead of time, the y values were the same. If y equals 1 on a line, for two places, it's got to equal 1 everywhere. It's horizontal. Said another way, the answer is just y is equal to 1. You could have skipped all this work if you made that observation ahead of time, and that's the answer. For this very last one, we will not be able to write this as y equals mx plus b, but let's see why this happens. The slope is 5 minus negative 2 all over negative 4 minus a negative 4. That is 5 plus 2 over negative 4 plus 4. There's no number that this simplifies to. This is undefined. And the second this happens, there's no way you can write this as y is equal to mx plus b. So that's no good. And the reason is there's no way to get a number for m. But if you check out the last example, y was 1 for both points, meaning your final answer is just simply y is equal to 1. By analogy, notice that the x values are both negative 4. That means x must always be equal to negative 4. In fact, this is the answer. X is negative 4. This was an example of a horizontal line. This is a vertical line. So if you notice that ahead of time, the x's are both the same, then this must be your answer.